Okay, so when we last met, had a lesson, it was last Wednesday, we looked at 1D collisions. Remember I had my track out for smashing parts and stuff. So today we're going to look at explosions and see how they relate, and I think you'll find it pretty simple actually. Common examples of the conservation of momentum center around two or more objects colliding in the absence of external forces. Another twist on the example of a collision would be the idea of a reverse collision or an explosion. If you videotape, dated reference, an explosion and play it backwards, it looks like a collision. Likewise, if you tape a collision, play it backwards, it resembles an explosion. If we look at the case of a cannon being fired, we find there is a force of the gunpowder exploding, creating a force of the cannon, pushing on the cannonball, and the cannonball pushing back on the gun. These two forces are equal in size, but opposite in direction. Because of that Newton's law thing, right? Equal and opposite that I was just talking about in my grade 11. Remember me saying equal lots in grade 11? Those of you that were lucky enough to have me. And then how much of a struggle it is for people to actually believe that. Equal. These two forces are equal in size but opposite in direction. If any forces that are external to the cannonball and system, such as weight and friction, are removed, then the momentum must be conserved. What does this mean right here? What is that little symbol, that funny looking thing with the E and then the P? What does that mean, do you think? The Greek, it's the Greek letter sigma, and it means sum of. So in other words, the total momentum. Fancy word way of saying total momentum. Okay? Sigma. And if you go on and you take any stats or anything like that, or even calculus, you will run into that. In the example on the left, the external force has been removed by placing the cannon on a frictionless surface. In the beginning, both the cannon and the cannonball are at rest. As a result, the total momentum before the explosion is zero. Since the total momentum of an isolated system means there's no external forces that's conserved, then the total momentum after the explosion would also be zero. So in other words, just like with collisions, PI, initial momentum, equals PF. But the beauty of it is that the PI for explosion is usually zero. So you don't even have to figure it out. It's just zero. So that's what I meant by with the easy part. Mathematically, we're going to make it look really confusing. Okay? So I'm just going to zoom in here a bit so we can see that a little better. So sigma P, total momentum, is equal to, what do you think this means right here on the right-hand side? Yeah, but what does it mean, Tanner? You're right. What does the prime mean? After the collision, right? So sigma P prime means total momentum after. So in my sort of connotation or vernacular, I would say something like, not E, what am I doing? PI is equal to PF. Those are equivalent. Okay? P cannon plus P ball is P prime cannon plus P ball. And you can see here that because of the negative value of the velocity, that the momentum before, they're both at rest, zero. The momentum before is zero, and because of those negative velocities, or that one there, you got minus 200 and plus 200, momentum is conserved. And if you can remember that, that is the fundamental pillar of the entire unit, really. You will notice that the cannon has a new velocity is in the opposite direction of the velocity of the cannonball. Remember, momentum is conserved, not velocity. So you might want to make a little note of that. It's momentum that is conserved, not velocity. How come the cannonball is traveling at a whopping 40 meters per second, but the cannon is only going backwards at minus 2? Because it's much heavier. Exactly, right? The cannon is 100 kilograms, the cannonball is only 5. So the mass of the cannonball is 20 times smaller than the mass of the cannon, and as a result of velocity, the cannonball is 20 times larger. Consider what would happen if you had a cannon with a small ball and a ball with a large mass. Well, it would be the cannon that would be going firing backwards, and that would be bad for the people that are operating the cannon. The concept of momentum being conserved in an explosion is true for an explosion along a line, one-dimensional, an explosion along a plane, two-dimensional, or an explosion in free space, three-dimensional for something like a hand grenade. So you literally can blow up a hand grenade and calculate the momentum, and when all those three-dimensional vectors would all add up to 0. Will we have to do that? No. I'm not going to make you do three-dimensional, but I will make you do two-dimensional ones. So it'll be like an exploding thing that only goes sideways. Suppose an example, the 5 kilogram cannonball moves with a speed of 25 meters per second after explosion. How fast will the 100 kilogram cannon move backward? Do you guys have this too? Do you have that on?
Yeah.
It's right there? Okay, so can we do this one as sort of an example? In fact, do you guys have this math right here? So really, all it's going to be is exactly that again, but instead of the cannonball moving at a speed of 40, after this 40 here is going to be a 25, right? Or do you want me to write it all out? How do you want me to do it? That's good, just like that? Okay. Oopsie. So 5 times 25. 5 times 25 would be 125, I think, right? Oh. You know what? I'm going to write it up. I apologize. This really wasn't solving for anything, right? It was just showing that it was conserved. Yeah, let's write it out. Can we just put a big fat 0 on the left-hand side? Sure, right? We don't need to write all that. So PF is going to be P cannon prime plus P ball prime. So that's going to be 100 times V, that's a C, VC prime plus, and the momentum of the ball is going to be 5 times 25. So 100 VC prime plus 125, and that's all equal to 0. Why is it equal to 0? Because the whole thing's at rest to begin with, right? So this is going to be minus 125 is equal to VC prime, which means that velocity cannonball prime is going to be minus 125 divided by 100, or minus 1.25 meters per second. I'll pause. Alrighty. So I've got 2 examples. Shall I do this one, or do you want to try it here?
I give him a shot.
Hey? Give him a shot?
Yeah.
Firecracker sitting on a tabletop, it explodes into 2 pieces that are 100 grams and 200 grams. After the explosion, the first piece moves to the left at minus 1.2. How fast does the second piece move? So it's basically the same thing. Did you notice that the mass is in grams? You do see it now. Do we need to worry about that? The answer is no. As long as both of the mass units are the same, they're both grams or they're both kilograms. As long as there's not a mixture, you're okay. So if you want to leave it like that, you can. If you want to change them to kilograms, that would just be 0.1 and 0.2, which are pretty easy to work with as well. So how do we start it off? Well, I like to start with PI equals PF, because that, sets me up for the whole thing. The initial momentum is equal to the final momentum. It's just sitting there on a tabletop. What's the initial momentum? 0. I like these. It'll work on the left-hand side. Final momentum is going to be 1 prime plus 2 prime. Should we call them 1 and 2? Is that okay? And I guess just for the sake of completeness, I will say momentum 1 prime is going to be mass 1, velocity 1 prime plus mass 2, velocity 2 prime. You don't need to do that step if you don't want, but maybe for notes we'll do it. The mass of piece 1 is 0.1. Not sure what happened there. I must have pressed something. So that's going to be 0.1. The first piece moving left at minus 1.2. So minus 1.2 goes there. The mass of part 2 is 0.2, and we need to solve for V2 prime. 0.1 times minus 1.2 is going to be minus 0.12 plus 0.2 V2 prime. So in other words, V2 prime is going to be that minus 0.12 is going to go to the other side, become positive. So it's going to be 0.12. And we're going to divide that by that 0.2, which is times by 5, which is, I think, help me out here, I think it's 0.6 meters per second.